problem, we're asked to find the domain of g. G is a function that has x minus 7 in the numerator and x squared minus x minus 6 in the denominator. So the first thing I do when I see a domain question is ask myself, what can go wrong? The domain for a function is the set of all values represented by x that the function can handle. But often we think about the domain problem in terms of finding out which values the function cannot handle. And depending on the structure of the problem, you'll either go after ones that can or ones that cannot. Just when we get to the point where we're going to list our answer here, we have to keep in mind that our goal is to find this set of real numbers represented by x for which the function will return a value. So after I notice the domain question, I start thinking about what can go wrong. What can go wrong here is division by 0. The numerator itself, x minus 7, as an independent set of calculations here, x minus 7 can be resolved no matter what the value of x is. Same with the denominator, x squared minus x minus 6. No matter what x is, this will return a value. The problem lies in the division. Division is only defined for non-zero values. If we attempt to divide by 0, we do not get a real answer. So the structure I'm looking at here, since it's involving division, leads me to ask the question, when does x squared minus x minus 6 equal 0? And again, the solutions to this problem will be numbers that are not in the domain. So the domain will be everything except when this happens. But notice we've reduced this problem now to a very familiar one. We have solved quadratic equalities a number of times, and there are a couple of techniques we can go about to perform this. But the key idea here is we've taken a larger problem, a domain question, and we've reduced it to one that's more familiar to us. So now you think about your skills in terms of this new problem and proceed. Again, it's a degree 2 polynomial, so writing this as a product would be nice. In other words, factoring it would be a useful step. But as we recall, factoring is sometimes easy, sometimes hard, sometimes impossible when we're dealing with real numbers. So I will attempt this. If I'm successful, I'll proceed. But also remember that if we cannot do this, if we cannot figure out a way to do it, we can always go with the quadratic formula. The quadratic formula will not only tell me the values that make this 0, but it'll also tell me if there are no values that'll make this 0. So start with factoring, give it a good shot. If you can't, use quadratic formula as your fallback. In this problem, since I've got a leading coefficient of 1, I know x's belong in both of these places. So when I multiply this out, I'll have an x squared. I want to end up with a negative 6 when I multiply the two constant terms together. So I'm looking for either a 1 or a 6 or a 2 and a 3. And since this is negative, the signs on these two numbers will have to be opposite. When I sum the middle two terms that are going to be linear, constant times x, I need to end up with negative x. So if we think about our options here, 3 and a 2 work, and putting the negative on the 3 and a plus on the 2 will again allow me to end up with the negative x, which is what I want. Now that this is written as a product, we can break this product into two problems. Where is x minus 3 equal to 0, and where is x plus 2 equal to 0? This will happen when x is 3 or x equals negative 2. All right. Now again, we don't want to circle this and imply that this is the answer to our problem. It is the answer to the problem that we've written for ourselves, but we need to now answer the problem that was posed to us, which is the domain question. So our answer here is all values except x equal 2 I'm sorry, x equal negative 2